The first step in any hypothesis testing is to list all the information we need. Now, if we're doing a single sample proportion hypothesis test, then the list is going to include the following things. To begin, we'll start by listing p hat. P hat is our sample proportion. This will be the percentage, but it'll be in decimal form. So make sure that when you write this down, it's somewhere between 0 and 1. After p hat, we'll list n. N is our sample size. And unlike confidence intervals, we don't list z here. We don't know how much evidence we have yet. That'll be gathered during step 3 of our hypothesis test. After we have p hat and n, the final thing we need to list is p naught. This is our new thing, and this is what we call our assumed proportion. This is what we're going to be comparing to. And this is dependent on what we're actually trying to prove. So in order to see this, let's go ahead and look at an example. This is actually our first example looking at military testing shenanigans. Now this is from 1955, and what we're looking at here is what happened to people on the filming site versus what happened to the general public. The important thing to realize here is, first of all, I want to do a hypothesis test. And I want to do a hypothesis test right away, I can tell, because I want to know, can we conclude? As soon as I'm trying to conclude something, as soon as I'm trying to prove something, hypothesis test. I also can tell it's a proportion hypothesis test because I'm dealing with percentages and out of. So I have proportions and I have a hypothesis test. Which means my first step here should be to go ahead and list the things I need. First thing I need to do when I make my list is to list p hat. P hat is the percentage of people out of my sample. Notice that although I have a 13.6%, that's not the percentage from my sample, right? That's what experts predict. I need p hat to be from my sample, and so looking at this a little bit better, I see it's in all 46 of the 220 people. And so as soon as I see out of, that's going to be a percentage there. And so all I'm going to do is I'm going to write 46 over 220 as p hat. When we run the test itself, we'll go ahead and convert that to a decimal, keeping 4 decimal places. The next thing I need to list is n, the sample size. There were 220 people in total. And then finally, p naught. P naught is what I'm comparing it to. Well, according to my hypothesis test statement, can we conclude that the crew suffered a significantly higher rate of cancer than the public? So what I'm going to be doing here is comparing my sample, the people on the film crew, to the public, which means my comparison value should be the public percent, or 0.136. Let's go ahead and look at another example now. In our second example here, we're looking at the chances of having twins. Once again, the first thing we need to do is identify the fact that we want to do a hypothesis test. Can we conclude? Definitely a hypothesis test. Second step, make sure it's proportions. I see approximately 3%, and then again with the whole out of. So I know I'm dealing with proportions here. Since it's a proportion hypothesis test, I go ahead and in my list, I start by listing p hat. Then I list n. Then I list p naught, my assumed value. P hat is going to be whatever percentage out of my sample. Notice I have that 3%, but that 3% refers to all births. So that's actually not going to be my sample percentage. A study of teen mothers, however, found that 7 of 469, so it's going to be 7 out of 469, that's p hat. We'll go ahead and convert that to a decimal later on. For now, n, our sample size, is going to be 469, and p naught, our assumed value, 0.03. And I get that because it tells me 3% of all births were twins, and I want to compare teenage moms to the general public.